Hello and welcome. In this video we are going over a topic rising in relevance in the tech world as it gets more advanced. This is of course quantum computers. They have been a breakthrough technology ever since their discovery. Let's dive right into the topic. Before we get started on quantum computers and their applications, we need to discuss what the difference is between classical and quantum computing. Classical computers operate on the values of 1 and 0. Either value of 1 or 0 is called a bit. Bits are combined to form text and numbers. Quantum computers, on the other hand, operate similarly to classical computers but with a twist. The quantum computer operates on what are called qubits. Just like a bit, the qubit can take a value of either 1 or 0. Not only can the qubit have a value of 1 or 0, but it can be both at the same time. In physics, this is a strange phenomenon called superposition. Only when the qubit is observed, it can take a value of 1 or 0. So special circuits are used to measure the qubit and produce values based on the results. One qubit can be the equivalent of 2 bits. To measure the amount of bits that a number of qubits can take the form of, we use a simple equation of 2 to the power of n, where n is the number of qubits. This is an exponential equation, which means that each new qubit introduced to the system will exponentially increase the amount of bits that the system can produce. This was just a simple explanation of how qubits are different to bits. The key takeaway is that quantum computers' power is exponentially proportional to how many qubits it has.
Classical computers have been the standard of computing since 1974 and are in nearly everyone's household. Mobile phones, gaming consoles, and personal computers are all well-known forms of a classical computer. Computers are required to solve millions of calculations per second to allow us to communicate with the outside world, watch movies, and play our favourite games. Scientists and mathematicians use computers for other issues, such as solving complex equations and calculating irrational numbers. There are many problems that a classical computer cannot solve, and this is when the quantum computer starts to shine. The first quantum computer deemed powerful enough to begin solving unsolvable problems was created in 1998. This quantum computer had only 2 qubits, which was impressive for its time. The idea of a quantum computer was in development for many years and had been finally created to a usable extent. Today, quantum computers are being developed with up to 60 plus qubits. With our current iteration of quantum computing, we can use quantum annealing to solve optimization problems with extreme ease compared to classical computers. For the use of magnetic fields, known as bias, and quantum entanglement, a QPU can quickly model physical problems and locate the lowest energy solution in a single computation.
We've talked about background history of a quantum computer, but now let's actually talk about some applications. What are quantum computers used for? Quantum computers have currently only been used for specialized tasks such as creating unbreakable encryptions and solving unsolvable mathematical problems that classical computers cannot. Funny enough, quantum computers do not actually process mathematical problems faster than classical computers. They instead reduce the number of steps to solve the equation. Watching videos on YouTube or writing documents will not be any faster on a quantum computer, hence the reason why they are a specialized tool for solving complex equations that classical computers simply cannot. Quantum computers will not replace classical computers. Instead, they will be used alongside classical computers, where the classical computer will process all of the simple and basic tasks. Because quantum computers are only good at solving extremely complex tasks efficiently, classical computers will still be used in everyone's household. This is also because quantum computers cost many times more than a classical computer and can take up to an entire room.
There are many current technologies and processes that can potentially benefit from quantum computing. As it stands, the general computer user that browses, creates and edits documents, and plays games will not benefit much in the near future. However, for scientists, researchers, and finance workers, quantum computing is showing a lot of potential for increasing efficiency in the near future. Processes such as optimization, machine learning, and simulation are all processes that can potentially be run on a quantum computer, allowing a faster and smoother process than compared to a regular PC. Quantum computing also has the potential to break the current limitations in chemical and material sciences, through the added possibility of calculating increasingly complex interactions of atomic structures. Getting quantum computing to this point will be tricky, however, as the current costs of quantum computing are far too great for all but the top research industries.
In conclusion, quantum computers and classical computers are fundamentally different. Classical computers use bits to represent data which takes the value of 0 or 1, whereas quantum computers use a quantum particle with a spin to either have the value of 0 or 1 or both at the same time. Classical computers were first widespread around 1975, and the first quantum computer was created in 1998. New things that quantum computers provide over classical computers is an unmatched ability to solve extremely difficult mathematical problems that are unsolvable to classical computers. A misconception is that quantum computers will take over all computers. This isn't the case, as classical computers are many times cheaper, take up less space, and are much better at processing simple tasks such as loading a YouTube video or writing the transcript for a video assignment. New technologies such as quantum encryption have been invented and are being used to provide unhackable protection for data. The most likely future applications of a quantum computer are of course, solving extremely difficult mathematical problems, but in the form of atomic structures or chemical reactions. This will allow for faster development of physics and chemistry sciences. Thanks for watching. Here again will be a list of everyone in this group assignment.